It's also this, creation of military forces pretty much everywhere in the world. So with the new space industry is developing at a very fast pace all over the world, from 6 in 1966 to more than 80 countries owning satellites in orbit. Now, 61 countries have a space agency. That means that we create a space agency pretty much every year. Space is everywhere in your life. When you get up in the morning and you look at the weather forecast on your mobile phone, you use space. You're in the street and you receive a WhatsApp from your son asking for money. Sounds familiar, isn't it? You use space. And then you wire money to him. And you know that during the transaction, it will be recorded by some atomic clock on one of the Galileo satellites. You use space. In the evening, you go to dinner to some friends, and you use the global navigation satellite system to go quicker. You use satellites again. And there, you discuss with your friends, and you learn that one of your friends is lost at sea during the Route de Rome. But fortunately, he was spotted, and he will be rescued thanks to the COSPAS-SARSAT system. So basically, our life have become dependent on satellite equipment, whether for telecom, for defense, for navigation, or for climate change. Hence, the explosion of the new space system, with the production upstream, with the production of nanosat infrastructure, IoT, Internet of Things, equipment, logistics, etc. And downstream, so here on the picture, you can see all the new, this is pretty much the French new space. Downstream with the production of many new services in the field of environment, water management, or even methane or carbon monitoring. We're thus seeing an explosion of public investment and private investment in the space sector, from $36.3 billion in 2000 to $170 billion in 2023. With the big players that you can see in the slide, of course, the US, China, Japan, France, and Russia. And an exponential growth in the number of launches carried out in the past 10 years. This picture is quite impressive here. Down the picture my pointer is not working quite well, but you can see this, the explosion of the number of launches. We will reach 2,600 launches in 2023, compared to 10 years ago, 240. Of course, this transition to mass launches brings with it numerous consequences, benefits and risks for the Earth, and that's what I'm going to talk about now. I'm going to start with the benefits because before serving to make kittens video available, the space industry was first and foremost serving science. Understanding the universe, the sun with solar orbiter, you can see this great photo on the slide. Understanding the solar system, Jupiter with JUICE, or Mercury with Bepi Colombo, and very recently the James Webb Telescope. I'm sure some of you recognize the fantastic photo given by the James Webb Telescope. And James Webb gave us the chemical composition of exoplanet atmospheres. He gave us also the first infrared rays of the universe. Science has long been the essential reasons for launches, for rocket launches. But satellites not only have been watching the universe, they also have been watching the Earth. And this since the 1960s for weather forecasting, but also from the second half of the 1980s, as you can see in this slide, to highlight the hole in the ozone layer with the NASA Nimbus program. This is where when the United Nations Convention on Climate Change was created following the Rio conference, the scientists all over the world mobilized all the emerging remote sensing tools to measure various factors of the system Earth that you can see on these slides. So system Earth is characterized by a growing number of factors just to monitor the whole climate change. And scientists create this network to understand network, which is called the Climate Earth Observation System, and the Global Climate Observation System satellite. And this is, what you have on this slide, is what is called the essential climate variables. 55 of them help the scientists to monitor the climate change and to modelize it. On this 55 climate change variable, 55, they are, more than half of them, 60% of them, can only be documented from space. Along these essential measurements is also what we call altimetry. And here you have Topex Poséidon, that is one of the first satellites sent by the US, by NASA and CNES, 1992 by Ariane, making the first measurements of height from space, and especially the heights of oceans. And since then, the scientists have been able to highlight not only the level of the rising water levels, but also its very uneven distribution. As you can see on the slide at the bottom, where it's red, you have a very quickly increasing level, and other areas of the world where it's not increasing as much. And also, they make us understand the respective contribution of melting ice on glaciers and the rise in temperature to understand the elevation of the water levels. Quite quickly, satellite resources were also devoted to emergency rescue. And here you have the presentation of the International Space and Major Disasters Charter that has been created 20 years ago. And it provides real-time information for civil security. This charter has been activated since its creation in 20 years ago, 869 times. Last time it was last week in Mozambique and in Mongolia. And climate change provokes, of course, an increasing number of major disasters. Just a quick word about Copernicus also. The unique Earth observation system, the European Earth observation system that has been launched in 1998 and operational in 2014. To better coordinate the data that were dispersed between different projects and entities and sciences. The European Commission spent more than 7 billion euros in making this, to establish this network of Earth observation satellites. And these satellites, as you can see on this slide, this is the Copernicus Climate Change Service, one of the Copernicus services that is offered to the world. And you can see there the various information that the Climate Change Service is giving us. The temperature, surface temperature, of course, but also monitoring carbon dioxide. On the bottom right here, you have the concentration of nitrogen in space during, before COVID and during lockdown. You can see in real time the importance of the reduction of activities in the concentration of nitrogen in space. Just a quick word about the Space for Climate Observatory, which is also an international alliance created in 2019 by President Macron. During the One Planet Summit. And here, in this international alliance, you have more than 47 agencies and international organizations such as UNDP and UNEP, United Environment Programme. And they develop together operational projects just to help territories to adapt to climate change. Nowadays, we have more than 71 projects all over the world, which are developed with end users, just to to answer to specific problems they have for adaptation. And they're working in this project are basically focused on the protection of biodiversity, forest fire protection, but also deforestation, tropical deforestation, and in real time. The SCO digital toolbox offered data, free data, that are coming from, that I developed through the projects, and they offered free through platforms, through Data Terra, also infrastructure. And now you can find all those algorithmic bricks also freely on the Geo Data Hub. Among a flagship project, we can find Stockwater, this very important, very interesting project which measures in real time the water stocks available in the dams everywhere in the world, live. Also, Litosat Bretagne. Litosat is a platform that offers to the local administration live data about coastal submersion, as you can see here. However, the increase of these activities raises crucial questions about their sustainability, whether in space or in orbit. Space is in fact the only industrial activity whose effect extends beyond the troposphere into the stratosphere. And one of the most worrying issues is one of space debris. In the last 2 years, there has been an enormous increase of the number of commercial satellites launched to near-Earth space, which means in low orbit. Many of these satellites are being launched into large constellations in order to provide communication services around the globe. There are nearly 6,500 operational satellites in orbit alone, and more than 9,000 in total, including the inactive ones. But apart from these satellites, we also have objects, as you can see on this slide, in the graph on the bottom of the slide. 900,000 objects over 1 centimeter, 34 objects over 10 centimeters. Scientists say today that we have reached the beginning of the Kessler effect. So what is the Kessler effect? The Kessler effect is a situation where orbital saturation produce its own waste through collision, increasing collision. So more collision produce more waste, which produce more collision, and so on and so forth. This is called the Kessler effect. We have counted 38 avoidance maneuvers from the International Space Station since 1999, and just last year, 4. So that's a symptom of the starting of the Kessler effect. Today, the community is mobilizing all over the world, albeit late, on the environmental footprint of space activities. It is clear that the most obvious, which is launches, is far from constituting the highest footprint. Emissions of particles in the upper layer of the atmosphere linked to the combustion of the propellant cause effects that are currently poorly understood. We don't really know what it does in the upper layer of the atmosphere compared to the pollution that can be done with the same combustion on the Earth. On the other hand, we have chemical reaction that depletes the ozone layer. And this is, and always has been, the main concern regarding rockets' emissions. Other particles injected into the stratosphere absorb and reflect also solar energy. Then they modify the flow of radiation in the atmosphere, heating the stratosphere and cooling the surface. This is what we call the radiative forcing effect that has the effect of modifying the whole albedo of the Earth. And therefore, it's also modified the quantity of energy that is injected into the atmosphere, which also provoke thermal changes, which also contribute to the depletion of the ozone layer. And finally, we also have great uncertainties regarding the impact of the thermal erosion of metals during the atmosphere re-entry of objects, being launches of satellites. And the measurements of metal particles and their persistence remains to be done. So now we are working on this. Many research is being done about these various effects, radiative forcing and thermal erosion and metal erosion. Here, just maybe not to describe in detail these slides, this is just to show you that scientists have been working to try to do a life cycle assessment of various types of satellites. In blue, you can see what is linked to the launches, the rocket launches, and the propellant emissions. And you can see it's very variable from one constellation to a single satellite. And here, there are two slides, one with a linear scale and the other one with a logarithmic scale, just to show you the difference of CO2 footprint between various types of satellites. The telecom LEO in low Earth orbit and exploration or Earth observation, meaning that the thousands of satellites that are currently being sent on low orbit are actually very, very worrying in terms of CO2 emissions. And so in the long run, we really do have to think about what type of satellite we're launching. Thinking about, we have to think about, do we really want to go to 6G and send thousands of satellites? So to finish, I'm just going to skip this one, but there are also lots of local impacts because of spaceport. We are currently building pretty much one spaceport a year. There are 27 on the globe, and with the rise of small sat, we're also building more spaceports, meaning more impact on the local biodiversity. To finish this talk, we have to think about what we want for our future. Of course, the space industry is essential, as I've tried to explain, essential for Earth observation, for science, for fighting against climate change. But today, space activities must, with citizens, ask itself essential questions about its future development. What do we want? Should we allow highly emitting space tourism to develop? Should we take our place in the race to mine Moon and Mars? Doesn't this race risk leading us to our own downfall and ultimately making space unusable? Should we instead focus on scientific research, scientific exploration, and climatology? I had the last one, sorry. Space is a common good, and as citizens, awareness of these issues is crucial. And for me, for everyone working in the space industry, citizens' expression in this subject is essential so we can prioritize what we want to do in the next 10 or 20 years. Thank you.